Okay, next big concept in post-Keynesian economics. Do you remember the neoclassical thing about if this is total savings, like say the households are over here, and this is total investment, the firms are over here. They have to be equal, first of all, savings and investment. And furthermore, not furthermore, let's say we start off with them equal and we're at full employment, but then for some reason firms decide to invest less. That could cause a recession. But that induces the financial sector to lower interest rates because they're still paying interest on this, but they're getting interest on this. And they don't want that. They don't want to be paying. Look at the gap right there. That's how much money they're paying interest on and not getting anything for. So they want to either raise this or lower this. And the same thing accomplishes both, and that is lowering interest rates. So they lower interest rates to raise investment and lower savings and until they're equal. And then what this does, not even by their intention, it makes sure we don't have a recession, or at least the recession is short-lived. The interest rates adjust and we're all saved. Keynes said that ain't how it works. Keynes said it works this way instead. When investment falls, it causes a decline in their income. And when their incomes go down, their savings go down. So we just go into a recession, period. There is no automatic corrective mechanism. And that's bad, all right? We need to do something about that. Well, let me show you the explanation of how he comes to the same conclusion that S equals I, but via a different route. Now, let's see here. Well, we're going to, just as we did before, we're going to deal with y is equal to c plus I, and, that's all I need. Yeah. The total spending is equal to consumption spending plus investment spending. We're going to get rid of the government sector and of the foreign sector for simplicity. But we're going to talk a little bit more about consumption this time than we did under the previous model. And we're going to say that consumption is a function of total income. If this is consumption and this is total income over here, then you would expect that as total income rises, so would consumption. And Keynes said, yeah. And assuming we scaled both of these identically, initially, at very low rates of income, you got to spend everything, all right? So if this says 100, that says 100. If this says, 40,000, that says 40,000. Over here, you're spending everything. But people would rather not spend everything. People, because the world is uncertain, would rather hold on to some savings even if they're not getting paid interest, because the world is a scary place. So, as we get to, I'm sorry, I didn't mean to make it sort of jump up at a steeper slope there, but as we get to higher levels of GDP, so consumption per dollar of spending, consumption per dollar of income goes down. I probably shouldn't be doing so many of these videos in a row. I'm really tired right now. All right, so here's our consumption function. Consumption is a function of income plus sign. It's not a stable, well, it's a stable function, but it's not a straight line. It's not a linear function. It flattens out as people have more income. And indeed, in really poor societies, they pretty much spend every penny they get in income, whereas we are able to save. And furthermore, even within the United States, the richest 20% tend to spend 60% of their income. The other 80% spend about 95% of their income. So the poorer you are, the more you spend. All right, well, so we want to lay it out. And remember, if we're explaining consumption, we're simultaneously giving an explanation of savings, too, because those are the opposite extremes. I'm not sure what the dog sees. I hope it's the mailman, because I have a package I've been waiting for. Now, here's the problem with this, though. I can't make up, that's bothering me that it's not quite straight. Let me fix that. Yeah, that's better. All right. The problem with this is we can't write a nice, neat equation for this blue line. So let's pretend we don't have the blue line. Let's pretend we have this line. let's pretend we actually had that straight line right there. Now, why would we be able to do that? Well, if we're dealing with an economy that's bigger than, say, this big, well, then the red and the blue line are practically on top of each other, all right? So if we're dealing with a relatively wealthy, developed economy, then the red line and the blue line are not far different. If we're to the left of it, they're really spreading apart there. But if we're not, if we're dealing with a developed economy like the U.S., well, then they're almost the same line, and we can actually draw a nice, neat, simple equation in that case. So let's do that. This is that equation. B becomes the percentage of new income you tend to spend. If it was like, and it's a macro concept, it's not just you, of course, but if it's 0.8, then that indicates that for every dollar's worth of increase in incomes, people spend an extra 80 cents. They save 20 cents of it. So this is going to show you how much people save versus consume out of their income. If it's 0.75, then for every dollar's worth of new income somebody gets, they spend 75 cents of it, and on like that. Can't be bigger than 1 because this is a macro model. You individually can spend more than you earn, but the macro economy cannot. All right, so this is a macro model. Can't be bigger than 1. Not going to be smaller than 0. Probably not going to be anywhere near 0. And this is going to be really important. All right. Now let's substitute this equation into this one. Oh, I'm an idiot. I told you I shouldn't be doing so many of these videos in a row. But Lord, it's getting close to the semester start, and I want to get all this knocked out. Okay. That took the place of C, right? You put that in instead of C. Hey, now let's get all the Y's on the left-hand side. Now let's factor out Y. And now let's divide both sides by 1 over b, or actually what turns out to be more convenient, multiply both sides by 1 over 1 minus b. Ta-da! You see it? Yeah. This bottom equation here is going to be really important. Y equals 1 over 1 minus b times A plus I. And if you've already had macro, you're probably ahead of me on this and saying, I know what that is. That's the multiplier, or technically the income multiplier. Although, if you hear an economist just say the multiplier, they mean this one. But there is more than one multiplier. But this is the one that we generally just say the multiplier for. So so let me show what that number means. First of all, notice, well, no, don't notice anything. Let me show what that number means. Let's go with that 0.8. B equals 0.8, and figure out what 1 over 1 minus b would be under those circumstances. 1 over 1 minus 0.8, which is 1 over 0.2, which is 5. All right? So the multiplier is 5 under those conditions, which means that if investment goes up by $1, GDP goes up by $5. If investment falls by $1, GDP falls by $5. Real world multiplier going to be closer to 2.5, 3, something like that. And but this is an easy example to do right here. That's bothering me. Let me put a 0 right there. So you notice here then that if investment is volatile, as it's going to turn out to be, its impact on GDP is out of proportion to its actual size. For every $1 worth of change in investment, whether that be up or down, we're going to get a more than $1 change in GDP, and that's important because this number is very unstable. And so it creates instability over here. We rarely see big changes in consumption. Consumption tends to be, in this sense, consumption tends to follow Y. In fact, let's put it this way. Changes in investment tend to cause changes in income, which tend to cause the changes in consumption. We don't typically see recessions caused by people stop spending. We do see recessions caused by firms stop investing. All right? Because The followed investment causes the recession, and the recession causes consumption to go down. Anyway, that's just sort of a side point there, but I love this stuff, so I wanted to tell you. All right, so let's say we've got this 5 here. What exactly does that mean? How can it be that an increase of $1 in investment led to a $5 increase in GDP? I got to be really careful focusing here. I better not do another video for a while. All right, so let's see here. B is equal to 0.8, and 1 over 1 minus B is 5. All right, so what we should discover is that if we increase investment by $1, GDP should rise by $5. And this is how. Let's say this is our $1 increase in investment. TCU decides to add a little tiny horned frog on a chair in the new performance hall, which probably be more than $1, but anyway. And so they raised the income of the company that sold the horned frog by $1. So their income went up, these people, because TCU invested. TCU added on a little bit, something extra into the new performance hall they're building. And that raised income for somebody else, for makers of horned frogs. And so what do they do with their income? Well, some of it they spend. How much? Well, according to this, 80%. So they're all excited and they rush out and spend 80 cents, all right, on whatever. So notice already, now income has gone up by $1.80. The initial entity's income rose by $1, but then that allowed them to go out and buy something for 80 cents. So now somebody else's income has gone up by 80 cents. They only have 20 cents left, but they've got 20 cents plus a cool 80-cent worth thing that they have. So they still have the income. The income has been changed from dollars to something they bought for 80 cents. So then the next, whoever this was here, they spend 80%. Oops, yeah, that's right. And so they spend 64 cents and on and on and on, all right? So to this point, right here, incomes have risen by, I believe it's $2.44. Yeah. So far, by $2.44, and we're not done. Whoever received this is going to spend 80% of that and on down the line. And that's how the multiplier works. And guess what? It turns out that if you sit down with your calculator and you keep multiplying by 0.8 over and over and over and then add all the numbers up, you know what you get? 5. I actually did that one day because I love this stuff and I'm weird. So I sat down and got back in the days of the calculator. Oh my gosh, it almost is 5 now. It approaches 5 very quickly, by the way, and then you got little tiny increments that you're increasing by. So I don't know, like it gets to $4.90 pretty quickly, but then after that it takes a long time. Well, it takes till infinity, and I didn't have that much time. This is how the multiplier process is working and how it's connected to this propensity to consume is what this is called. The tendency to consume, right? And by the way, it's called the marginal propensity to consume. Remember the marginal analysis from neoclassical economics? And remember Keynes was a neoclassical economist at one point. So he's using that marginal analysis that he learned as a neoclassical. So what's happening here is that the multiplier process is causing the initial increase in investment to be multiplied out to eventually be a much larger number in the macroeconomy. So that's how the multiplier process works. Let's see, anything else about that before I actually lay out the model? I think that's all I wanted to do. Yeah, all right. Okay, so what? What does this have to do with savings equals investment and all that kind of crap? Got to double check the time here. All right, I got 14 minutes. What does it have to do with all that? All right, so here's how we set out Keynes's analysis. Remember that one I showed you from the neoclassicals on how savings equals investment? Here's Keynes's. So here's his 3 assumptions. And we've got y equals 1 over 1 minus b times a plus I, as I showed you a minute ago. I've made my bullet points too close together there, haven't I? We're also going to use this equation. And we're also going to use this equation. So what we want to find out, just as we did with the other example, remember we had investment, savings, investment fell. Oh no, they're not equal anymore. They will be. Same thing will happen here, but via a different route and with a different conclusion with respect to whether or not the economy is in recession. So, the way to show this one is with a mathematical example. And by the way, you have to figure it out in this order. What we're going to do is I'm going to give you B, A, and I to start with. So that means we can calculate Y. Then once we've got Y, we already had A and B. We plug this in here, we can get C. And then once we get C, we can figure out S. And we're going to check to see, is S equal to I? And it will be. So check this out. I'm going to start with investment equal to 50. B is 0.8. A is 10. Is that all I need? Yeah. So let's plug in that first equation. Y is equal to 1 over 1 minus 0.8 times 10 plus 50. There's A and I, and there's the B right there. Let me jot that down for you. B, A, and I. And if you multiply that out, that's 5 times 60. So GDP is 300. I want to wonder how much consumption was. Well, let's see. C is equal to, and I'll just plug the numbers in here, 10 plus 0.8 times 300. 0.8 times 300 is 240, 250. How much was savings? Well, savings is income minus spending, minus consumption. 50. Mon Dieu, as they say in economics classes in France. We started off with investment equal to 50. We went through the calculations. I'll be danged if savings doesn't also turn out to be 50. How about that? So, they're equal. All right. Now let's go back to the scenario we had before. Let's say they're equal and we're at full employment. So everything's awesome. But investment's going to fall. Investment's going to fall from 50 to 40 in my next part of my example. Let's see. I think I'll try to draw it over here next to it. Means I'm going to have to roll my chair. Well, no, I'll just get out of the chair. All right. Let's see. Now let's lower investment to 40. And let's see if it's still true that investment ends up equal to savings. And is it the case that total spending stays the same? Or are we going to have what Keynes said? Total spending actually falls. Right? And total spending, of course, was 300. So do we stay at 300 or do we fall away from that in the process of returning to S equals I? Well, let's find out. All right, so this time investment's equal to 40. So let's plug all those numbers in here. Y is equal to 1 over 1 minus 0.8. 10 plus 40. All right, so now we've got 5 times 50. 250. Sometimes it tries to focus on me, and who can blame it, rather than on the board, but I think that's legible enough. Then let's figure out consumption. Can't figure out savings until we figure out consumption first. Consumption is 10 plus 0.8 times 250. And it turns out that 8/10 of 250 is 200. So that's going to be 210. Savings is equal to 250 minus 210. Because 250 was total income, consumption was 210. And like magic, they're equal again. All right? So investment fell, but they're equal again. So the process by which they re-equilibrate is the fact that income falls, investment falls, driving down income, and therefore driving down savings until they're equal again. So this kind of sucks, because now the overall level of economic activity is no longer 300. 300 was getting us to full employment by assumption. We said let's start at full employment. 300 was getting us to full employment, and now we're at 250. Our new equilibrium is 250, which means we're not at full employment anymore. So that's the point Keynes was making. He was saying, look, there is not only is there no automatic mechanism in the labor market, but also that loanable funds theory that created this automatic mechanism out of the interest rate, that doesn't operate either. This is what really happens. And in fact, it's a lot more complicated than that, which we'll get to some of it here in a little bit. But that's the basic story. And I was thinking about doing this. What time is it? I have to be somewhere at 4, which is downstairs, but it's 8 minutes to 4. And let's see. Now, I'll hold off on that. Okay, so now we've got some money supply stuff coming up next. But otherwise, we're rolling, baby. We're rolling.